So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. So you think you need a home battery, maybe to power through home blackouts, maybe to time shift your energy use. And that's when you store daytime power in your battery and use the battery when utility power is expensive, as opposed to just kind of sending that power back to the utility under net billing tariff in California or elsewhere, where they're basically just giving you peanuts. So time shifting is how you save a lot of money. Or maybe you're interested in getting extra payments from your utility from something called a virtual power plant. We'll talk about that more later. Or maybe you just want to add a battery to your existing solar system. And maybe you want to add some more panels at the same time. So here's some candid, no bullshit advice from someone who's installed thousands and thousands of batteries going back 25 years to my old lead acid battery days. So we're going to start with some realities. First, not many complete battery systems that are on the market are reliable and widely code compliant. This is kind of a surprise. You think that sometimes, companies selling something that's going to work right out of the box, or lots of installers will be familiar with it. I can't emphasize enough to get a complete battery system. There's some companies or distributors who are going to sell you batteries from one company, a battery management system from another, in another box, an inverter in another box, and then hope that the software is going to work together. You must buy a battery system from one company. The company kind of packages everything. It comes in one big box or several boxes. And most importantly, that company must also design and manage all the software. The software is actually where many, many companies just kind of fall flat on their face as far as reliability. Second, there's only a few battery systems that are approved for third-party ownership financing. That's similar to the leases and power purchase agreements. Very, very common is something called a prepaid lease. It's basically a way for you to monetize that 30% tax credit, and that's done by the third-party ownership company. But they have a very strict approved vendors list. And all batteries aren't on all vendors lists. Third, some batteries are pretty easy to install once you kind of get the hang of it. And by the way, the systems all have to be installed by certified battery installers. So every manufacturer has their own certification program. But some battery systems, even if they're, if you're trained and they have the documentation, everything, they could be a pain in the neck to install. Or there's changes in the installation procedures that you may not know about, the installers may not know about, they constantly change. So ease of installation is really important. Fourth, there are some cheap battery systems out there, but if a cheap battery system doesn't really work as you expect, or only ends up being able to deliver the half of the energy, or it's down half the time, that's not cheap anymore. Fifth, I strongly advise you, if you're a homeowner, to trust your local installer who has a good reputation, that's been in business for a while, and knows what batteries are good and are not. And the good installers are typically going to be very, very comfortable installing maybe just one or two battery systems. Because if they try to install all of them, they're never going to be experts on any. And they've probably selected the ones that are the most reliable, which is really what you want. Okay, let's talk about some myths, uncertainties, things you may hear that in reality may not really be that true. First, battery systems are getting much, much cheaper. The reality is that the battery cells are coming down fast, but the battery system prices are still expensive because that system includes the inverter, the software, the packaging, the installation labor, and everything else. Although the cells are coming down, it doesn't have a tremendous impact yet on the total price of the system. I get emails every week from new battery suppliers, usually just battery cells. Hey, do you want to buy our battery cells really, really cheap? And I kind of look at it and say, what am I going to do with a battery cell? And even if they have a complete system, I've never heard of this company from somewhere else on the planet, I'm not going to take a risk on trying to see if that's going to work for my customers. I'm going to wait to see if they actually get mature enough to be successful in the market. Second, you may say, I want to wait for better battery technology. Well, that may have been true 10 years ago when lithium-ion batteries first came out, but experienced lithium-ion battery system manufacturers are already demonstrating exceptional reliability. So it works. Now, there is better technology coming out. The batteries are getting more powerful per unit of weight or size. There's new technologies that are coming out, like I keep hearing about solid state batteries. I've been hearing a lot about those for like a dozen years, not even close to being ready. And new battery chemistries, but you know what? The standard lithium ion battery chemistry, it works. That's what you want to get. You're not going to be like a test bed for some new technology and hope it works. And the third myth, just because you see a battery system being advertised on the internet and you can ship it to your house doesn't really mean that your local city is going to allow you to install that battery in a code compliant way and get a building permit and get it signed off. We sometimes get calls from customers who bought a battery system over the internet and wants us to install it. And I kind of look at it and say, I've heard of that system. And when I looked it into last time, it wasn't code compliant in some of our major cities. And it's just not worth the risk for us to try and get something to work. Experienced installers hate science projects. Now, before we get into comparisons of different battery systems, I'm going to go into the two most important specifications for batteries. Battery systems are rated by kW, or kilowatts, and by kWh, or kilowatt hours. Watch out for those two distinctions because although they look very similar, they're very different. kW is the maximum power output of the battery. Ideally, you want to make sure you've got a battery system that has at least 10 kilowatts of steady state output. Now, the batteries are also typically rated with something called a surge output or a higher peak output. And that's very important when you want to start large loads like air conditioners or a well pump. They all have higher surge currents and you want to look at that. But once you're over about 10 kilowatts of steady state power, then you're going to be able to usually start those larger motors. A kW, kilowatt, it's a unit of power. It's like horsepower. If the loads in your house, if you add everything up, are greater than the kilowatt rating of the battery system is going to say, oh, wait, it's asking me to start up too fast. I can't do it. Battery's going to shut down and not go into backup mode. And that's bad. And it's usually because when there was a blackout, there was too much power draw from the battery. Maybe the air conditioner was running. Maybe your EV was plugged in. Maybe you have a well pump that tried to start up and the battery said, I just can't really start that. The second important spec, we talked about that, is called kilowatt hours. It's the energy storage capacity of the battery. More kilowatt hours means your battery will last longer in a blackout. So kilowatt hours is a unit of energy. It's kind of like the number of gallons in your gas tank. And I suggest getting a home battery, minimum size of 10 kilowatt hours. There are some out there that are smaller. If you live in a little condo and if you really have a small electric bill, maybe a 5 kilowatt hour battery would make sense. But I would strongly suggest don't get anything less than 10 kilowatt hours. And if you want to run a heat pump or an air conditioner at night, or if you have a lot of things plugged in and running in your house all the time, like networking equipment or sound equipment or security systems, you want to get probably 20 kilowatt hours or more. And also the thing is that more kilowatt hours is good when there's an extended blackout because your battery is going to last longer. And if you have more kilowatt hours, you're going to be able to save more money by time shifting your energy use because you're going to have more capacity of the battery that you're going to charge up during the day. And then you're going to use that power at night when electricity is really, really expensive. There's two basic battery system designs. And I just kind of summarize them. They're either integrated battery systems or separate battery components. Now, integrated battery systems generally include like a 10 to 15 kilowatt hour battery and an inverter in one compact package. Now, unfortunately, that compact, smallish package is very heavy, typically about 300 to 400 pounds. And when you have something that's 300 or 400 pounds, it's kind of harder to move and hang on the wall, but it's very easy to wire. So what most installers have found is it's kind of generally better to, once they figure out how to transport and hang and install a relatively heavy battery, it's the fastest way and actually it's the most reliable way to get it connected because you don't have a lot of field wiring to do. You don't have, there's some battery systems out there where, we've got to make 50 individual wiring connections. And every single one of those connections is a possible failure point. So the fewer connections, the better. Having everything built in together is better, even though it's really, really heavy. The alternative is a separate component system, including the battery, the inverter, and maybe a communications box. And often these separate systems have multiple battery boxes. So you have maybe 4 5 kilowatt hour batteries each one of these batteries comes in a separate box. Each one of these batteries may weigh 60 pounds, and you unbox it and install them all together in an enclosure. That's easier to transport because you don't have to carry something that's 300 or 400 pounds, but there's a lot more work. So, and more work means more time to install, more work means more possible failure points. Both integrated systems and separate components are good if you have to move the battery like up and down a lot of stairs, or if you have a very, very small amount of available space, maybe separate components are good. But otherwise, generally what we found is it's more cost effective to install a heavy box that's got everything integrated, including the inverter. Now, speaking of inverters, it's an amazing thing that's been happening over the last couple of years. For 25 years, I've been installing inverters. First string inverters, and then starting in 2009, I started installing N-phase microinverters. They worked really, really well. But now what's happened, the big transition in the industry, is that some of the best battery systems have built-in inverters. So you have a box with 15 kilowatt hours of battery, plus you have a battery management system in that box, plus communications, plus a string inverter. And that kind of makes it easy to wire things together. So for new solar installations, basically, we just wire the solar panels directly into the battery. Typically, there might be 2 or 3 strings that we'll wire down. Each string is going to be on a different roof face so that they're all kind of operating about the same way. It's a really big time savings. Time is money. And it still provides excellent efficiency, and the reliability has been great. So when we're talking about these battery systems, it's not just the battery. There's several important features of battery systems that are becoming more and more popular. One is something called a meter collar. A meter collar is a device that allows an easy connection of the battery to the utility grid. So this is basically, it goes between the meter socket, that gray box on the side of your wall, and the glass meter enclosure. So basically that glass meter enclosure is removed by the utility. They put this meter collar adapter on, which is a piece of plastic with a bunch of circuitry and some components inside, maybe a couple inches thick. And then they put the meter back over it. Basically what that system does is it allows the battery system to isolate from the grid during a blackout. So there's some communication wires that go into that meter collar. And if the meter collar senses that there's a power failure, it basically automatically disconnects from the grid. And then the communications tell the battery systems, hey, we're operating in a blackout. Start backing up the house. And that isolation device is called a transfer switch. The key thing about the transfer switch and what it does and why it's legally required is it prevents the battery from backfeeding to the grid. So, just imagine you had a generator and there was a power failure and you plug the generator into an outlet in your house. Well, the generator power would go to your house, but if you didn't have a transfer switch, your actually generator energy, electricity would go to your neighbors onto the power lines, and that's dangerous. So there's a very, very important safety factor for all kinds of generators, including a solar generator, to make sure that if there's a blackout, they automatically disconnect from the grid so you're not backfeeding the grid. Now, sometimes with these meter collars, it's a little bit inconvenient because the utility you have to set up a separate meeting, right? System's all installed, you're ready to go. Oh, you can't turn it on, because the utility has to come out, take off their meter, put the meter collar in, and put their meter back. It's a 5-minute job, but here in California, the utilities actually don't allow the installer, even if they're trained to do it, they require a separate visit, which is an expense and an inconvenience, but that's the way it is. Another important feature, and this is something I can't emphasize enough, is something called load shedding. It's super important if you want your battery system to function really well during a blackout. The reason is you don't want to have an overload during a blackout, or you don't want your battery energy to go too low. So let's just go through some scenarios here. Let's say it's the summer, it's a hot day, late afternoon, your air conditioner is running and it's drawing about 6,000 watts. You have an EV charger plugged in, that might be drawing 7,600 watts. Your pool pumps may be running because you have a party. That's another couple of thousand watts. And then you got a bunch of other little appliances in the house. The refrigerator, lighting, TV, security system, entertainment. That could be another 1,000 or 2,000 watts. So what could happen is on that typical summer afternoon, your house is easily drawing more than 12,000 watts. So if the house is drawing 12,000 watts and you have a battery system that can only supply 10,000 watts, 10 kilowatts, there's going to be an instant overload. So when the power goes out because of a blackout or a power shut off, your battery system's not going to be able to turn on because the house is saying, I want 12,000 watts, and the battery can only put out 10,000. Okay, so in that scenario, there's a blackout. You have a battery. It's good. You paid a bunch of money for it. It's not working. The reason why it's not working is because there's an overload. If I have to remind you, this is a Gilligan's Island situation. No phone, no lights, no motor car, not a single luxury. Yeah, you're going to be bummed out and say, oh, God, what do I do? Well, if you have a load shedding setup, a load shedding system that'll automatically turn off the big power draws in your house in a blackout, you're not even going to notice. So on my system at home, my load shedding with my battery system, automatically, if there's a blackout, automatically disconnects the EV charger and automatically disconnects the oven in case my wife is like baking another carrot cake or something. So the rest of the things are working. It actually can power the HVAC system because I've got a relatively large system. So it's automatic. It's kind of a fail-safe thing. You might not even notice that your power's out because this load shedding kicked in and it kept everything running. And the other thing is your app that comes on your cell phone for your battery system, good battery systems have good apps, allows you to control things. You may say, all right, well, I got plenty of battery capacity. The sun's shining like crazy. I can turn off my air conditioning and I can keep charging my car. You can kind of manage those loads and it's very clever. It's very automated. And what it means, really two things, really, really important. First, when there's a blackout, you're going to have a good experience because the system's going to work for the things you really need. And second, when there's a blackout, you're not going to be drawing a lot of power from other things. So that's the other thing to consider. If your EV charger and your HVAC draw a total of 10,000 watts and you have two 20 kilowatt hour batteries, your batteries will be drained in only about 10 hours. And that's going to be a problem. Now, this load shedding can be done with a way that's integrated with the battery system. And some of the major manufacturers kind of have that built in, which is really handy because you got one app. Or there are companies like a company called Span that have special electrical panels that automatically can control these loads. You're going to have a separate app. It's a little bit more configuration, a little bit more confusing. It also is handy, especially for battery systems that do not include this kind of load shedding. Another alternative is what's called an essential load panel. Now, this is a simpler way of handling load shedding. Basically, what you do is you say, hey, these are the most important things I have in my house. This is my coffee maker, my microwave, my security system, the lights in the hallway and the bedrooms and some outlets, the refrigerator. You kind of figure out those essential loads and you put all of those essential loads in one electrical panel. You got to move some wires around to do it. It's called an essential load panel. And when there's a blackout, the battery system only powers that panel. That's a really good solution if you have a relatively small battery, say 10 kilowatt hours. And this is the way I designed my house initially, is I had an essential load panel and it just basically was powering those 5 devices, those 5 outlets. And it worked out pretty well. Yeah, I couldn't run the air conditioner. I couldn't run my car. Some of the lights in the house weren't working, but it wasn't the end of the world. And I had a good experience when there was a blackout, because when there was a blackout, basically the big things automatically turned off and I still had power for the essential things like my coffee maker. Your fridge can stay cold. Your lights are going to stay on. Your kids are going to have the internet. No Gilligan's Island situation. All is good. It's going to be a little bit more wiring. Might be another $1,000, $1,500 of wiring, depending on how things are oriented in your house. But it's a really good solution if you don't have load shedding and if you want to have a good blackout experience when that happens. All right. Next, really important feature. And this is not an option. This is really important. Is the software and the apps for your battery system. I would say that this is probably the second most important consideration besides reliability. It really separates the winners from losers with these battery systems. And it's not easy. I mean, because basically the software that's operating your battery system and the app that you get on your cell phone can't be done until your hardware is ready and you're pretty much in production. So it takes time to develop these things the right way. And there's many layers of battery system software. There's the software that you have to access your system, usually through your app. There's a software that's on there that allows the installers to configure the system. We're putting in there, this is how many batteries, this is how many solar panels, this is where it's located, these are the current. et cetera. You have what's called fleet management software. So installers, they have to keep track of, literally thousands and thousands of batteries. You have a way to do that in an integrated way on the whole fleet. And then you also have manufacturers software that allows them to kind of really get into the details within the system. And finally, many of these things are based on firmware. So they have to be regularly updated to your battery system. And that's something that doesn't always work smoothly. You have to have good communications. Naturally, there's an app for your battery where you can look at this app on your phone and you can see the power output from the solar at any given moment, the battery state of charge. You can see all kinds of historic performance data. So you can kind of go back and say, all right, how much solar did I generate this year compared to last year? Guess what? You're going to usually see a little bit of a decline. Why? Because your solar panels are dirty. Hey, it's time to clean the panels. Or you can see the state of charge of the battery and find out how much the battery was depleted every evening when there's no sun recharging it. It's actually, in my view, it's more work, more people involved to make sure that this entire suite of software is properly designed and operating than it is to design the product itself. That's why you'll find that companies that just buy a bunch of batteries to put into a separate enclosure, then they add a battery management system, then they add an inverter, then they try and write their own software. All these components come from other manufacturers. Very, very hard to write things in a way that's going to be reliable. And we see that happen again and again where you get these like cobbled together systems. And it may work if it's done perfectly, but it's confusing and they don't update it. Last but not least, reliability and battery warranties. Now, I kind of look at the warranty and the reliability as two sides of the same coin. All battery systems that are out there have warranties in the range. They started out at 10 years. A few companies are like 15 years. There's some companies out there that say they're 20 years. I laugh at them because they just have no freaking clue. Most of the times you think that a longer warranty is better, but there are many cases where the companies have long warranties or they even a regular warranty, like a 10-year warranty, and they have so many failures that they're not able to kind of keep up with the warranty repair. And we've had that experience. It drives us crazy. It's really expensive. So the most important thing, more important than the warranty, is trying to get some insights into the real world reliability of the battery system. Here's how I'm kind of wrap up this energy show with some real data about battery system reliability. We carefully track battery system failures. Now, there's calls we get because, a wire broke or some customers don't understand how something's working, or there's, something didn't work properly in a blackout. Usually it's a configuration or a minor change. It's usually software. We get that fixed. But the most important is when there's an RMA, a complete failure of the battery system. We track that very, very carefully. Here's a bar graph of the RMAs. It's return material authorization. That's the authorization we get from the battery company when we're going to send a battery back. And we track that. I'm not going to name names, but you see there's one company with like really, really low percentage RMA rate. And then there's another couple of companies that are in the middle of the range. And then there's another company that's just like off the charts. 100% on the average of their batteries had to be RMA, which means that not every single one, but sometimes we had to RMA more than one at a time. So obviously, I'm not going to mention names, but there's one major company that's far ahead of the others. And that's just a reliable product. And that's the one that most installers are going to be happiest to install. It might be a little bit more expensive, but the darn thing is just going to work. Now, obviously, if the homeowners are happy, the installers are happy. And if the homeowners aren't happy, if there's an RMA or frequent RMAs or repeated RMAs, drives me crazy. I used to have a lot more hair. That is very, very expensive for the installer, and you end up with very unhappy customers. And, we had to spend a ton of money over the last 5 years dealing with battery systems that just did not have the reliability we needed. The first graph I showed you was data from our specific RMAs. Here's another graph that we recently got, which is basically showing how reliable certain battery systems are during a virtual power plant event. Now, backing up, a virtual power plant, or VPP, is when a utility has the authorization to deplete your battery a little bit, occasionally. So maybe during a really hot summer afternoon or evening, the sun still may be out, but there's a shortage of power because the utility is trying to feed air conditioning and EV charging for everybody in a particular area. They may have a power failure, or they see this happening and they say, hey, we can add extra power on the local grid if we deplete half of the people's batteries by, say, 5 kilowatt hours over a 2-hour period. So that's what a VPP is. If you're enrolled in that, you'll get a little bit of money from the utility during a VPP event. And, it could add up to $1,000 or more, depending on the particular arrangement with your utility. It's a good thing to do. You make a little bit of money. It's altruistic. It's helping everybody out. I would say, without a doubt, you're helping the utility the most, and they're not, they're the one that are going to actually make the most profit, but it's a handy thing to do. But anyway, back to this VPP concept. This graph shows the battery system availability during particular VPP events. I believe this is an analysis that was done in Connecticut. And once again, there's 2 companies that are leading the pack, that when there was a VPP in, a hot summer afternoon, the utility said, hey, we need 10,000 batteries on the local grid to deplete, say, 6 kilowatt hours over the next 2 hours. There were 2 companies that really were able to deliver. Another company didn't deliver very efficiently at all. And I would say, most of the other companies don't even have the reliability to be considered part of a VPP. By the way, the 2 companies on here are really the only 2 companies that we've been installing for the past few years. Now, with regards to VPPs, shop around a little bit. You may find that I've seen some VPs that were ridiculously biased towards the utility or toward installation company. Basically, you would get peanuts for forking over your battery. And there's some programs like the DSGS program in California that is still available that actually would pay you, $300 or $400 a year for enrolling. So shop around for the VPP, really have a good understanding of how much money you're going to get for that VPP program. And don't be surprised when on, particular days, mysteriously you may say, hey, why did my battery discharge? It's probably because you're enrolled in a VPP, or you were automatically enrolled in a VPP and they're using a little bit of your capacity, and you're going to have to buy that capacity back from the utility. So kind of keep that in mind. There's an offset. Okay. Wrapping up, very simple. As an installer, we just want our customers' home batteries to work. That way, the customers are going to be very happy. And that way, we'll be very happy because our maintenance cost for this big fleet of batteries is going to be relatively low. So I would trust your local installer, especially if that installer's been in business for a long time. For efficiency, those local installers probably specialize with only 1 or 2 battery system manufacturers, not everybody, because they've realized and figured out through experience what's really reliable, and they've gotten really good and efficient at installing those systems. Your local installer knows what's best, and I would take their recommendation very, very seriously. That's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. If you missed any of today's show, you can always go to our website at energyshow.biz and listen to the podcast.
Thanks for tuning in to this week's Energy Show.